Hi everybody. Thank you for coming on a Sunday. It's a new thing for me. So we'll talk about more practical things, and I think I have only one formula in my presentation, so sorry about that. We'll talk about ports. So PIANC Association is the World Port and Waterways Association. So it's very much linked to what is going in the ACI and the ASCE and etc. Let's move forward. So we'll talk about some precast applications on the foundations of piers. Also, second topic on applications on bulkhead and float control structures, and a zoom on the superstructure of deck on piles. I wanted to say also that I'm here representing the South American or Latin American group of association of concrete associations. So I'm invited by them, and so that's why I'm showing some examples of projects done in Colombia and Mexico, in Argentina, and where I've participated. So first, we're going to the city of Shakira, Barranquilla in Colombia. So this project, and we have the designer here, Carlos Ospina is here, was designed by SDH, and we were the design builder. This is a multi-purpose cargo terminal on the riverbank. It's a marginal wharf, and it's a deck on pile type. Here also we'll talk about the piles in this example. We faced in this region, there is a hard layer, so I put in feet. It's about 30 feet depth of water. This is the dredging level, but at about 50, we have like a marl type, limestone marl rock layer that is quite high and is making problems to install a typical concrete precast pile. Usually we in this type of layers we switch to a board piles, cast in situ, or inside the sleeve, a steel sleeve, or we drive steel tubular piles, open-ended inside them. The first one is we don't do that anymore in our company. We try to avoid it because of the environmental impacts and the low speed of the solution. We usually move into the driven piles. This is fast, this is clean, and we go further with the superstructure. But during the genesis of the project, there was a spike in the price of the steel, so the owner didn't want to postpone the project, and so we developed a combined system with a precast concrete. So we came back to the precast concrete pile system, but we added some small steel element at the bottom, so as it can penetrate in this layer that is necessary for the correct embedment and bearing load. And what is this element? It's not a W beam, which is typically done, but we designed a small piece of pipe tubular and still open-ended element connected to the tip elevation of the tip of this precast concrete prestressed pile. This could generate a could allow us to enter and to penetrate this hard layer. Also to form a plug inside this open pile and increase very much the capacity of the pile. There's a lot of details here in the connection. So there's a plate at the end of the concrete pile connected inside with some it's like an insert, and afterward there's a welding with the tubular pile. All this element was precast on site with the help of our division, precast division in Colombia. And the typical section was 700 by 700 millimeters. Sorry for the millimeters. The concrete was 6,000 psi, so 42 MPa. So with the strands, it is prestressed, and the stinger with the steel pipe is a APA 5L grade 60. And we can see, so here the precast, the beds and prestressed beds, and here the lifting, so it was brought by barge, lift up and installed there in the piling template. So this is the first recent innovation that we developed in the past years. Let's move a bit up towards the shore, and let's talk about bulkheads and float control structures, always with precast elements. So usually we use steel sheet piles. We can build diaphragm walls. We can build some second concrete piles. We can excavate at a large scale and install precast L-shaped walls, or even reinforced earth can be used. But in some soft cohesive soils, the access and close to the water is difficult to excavate. So the precast solution is a good way to look into. On this previous job in Barranquilla, we developed there something on the back of the wharf. So these are the panels retaining the soil, the earth on the back side of the wharf. So there is no load on the top. So this is why it worked very well. It's just maintain the slope as it is. And these panels were installed after the superstructure or during the superstructure construction, and were resting on the longitudinal beam on one side, and on the other side there was a key here, a sheet key, that connected to this thick slab on the edge, and all together were connected at the end with the casting placed topping concrete material. This is behind the wharf. Other solutions that we have implemented since quite a lot of years ago in Colombia, also, and especially in Bogota, but there are applications along the shore too. These are the precast sheet piles, not steel, but concrete. Steel is expensive, as I said before. And in some countries, a lot of countries, they don't have steel mills and they have to import, and the tariffs, etc. So concrete is more local resource. So these CZ soil solution sheet piles, concrete pre-stressed sheet piles can be hammered, driven in the soil, or installed in a slurry excavation and form a retaining wall. The other solution, when you don't have, you can use some smaller equipment, panels, shorter panels, like small piles, and put together, still pre-stressed precast elements, and installed with an impact hammer. And there is a key in between, and you can also inject here this area for the tightness, water tightness performance. And again here, lift up and install inside the template. Coming back to this application, or larger elements are panosols, or a panel in Spanish, or in French even panel, can be used and installed in the slurry or driven in ground. And the application for float controls is here at the top of a berm to have a protection higher than to increase the level of the protection, instead of using and bringing a material that can be washed away during the flood. For more heavier and higher height of retaining walls, there was this development that was done, building an A-frame. It's almost an A-frame type. So avoiding replacing the typical tie rod and an anchor system on the back. This is a hammered, driven pile, inclined pile here. So it's like a leg, and we connect it to a beam at the top part, and to the top of these precast panels, and all together this frame worked out very well. And there is a important saving in the concrete volume, because the initial design was a cantilever like diaphragm wall or panels of 60 centimeters thick, and it was reduced to almost half of it, plus the anchor. But overall, there's a big saving here, and also the time of the construction is smaller, reduced. All these elements, so this is done in Colombia by our company, and they are CI 318 compliant. All the concrete is a class C2 S1. We're using 60,000 PSI compressive resistance, water cement 0.4 max. And this is a view of our plant in Colombia, and that is also deployed at a small scale in the other countries of our company where we have projects with Precast. I wanted to have a focus because I recently arrived in the region, and I'm seeing a lot of epoxy coating on the rebars. So we see that we are not using that, and we are focusing more on respecting strictly the concrete cover, and a very good mix, concrete mix. So as there is no risk in case there is damage of the epoxy coating during the transportation or the installation, because these structures and the next project that we'll talk about, there is quite a lot of high density it's very dense in terms of rebars, and the epoxy coating could be damaged, and I'm not sure if it is actually properly repaired before pouring the concrete. So let's focus on respecting the 3-inch the 3-inch concrete cover, and on the faces, the critical faces of the concrete, and a very good concrete mix with a good small low permeability if possible. The last topic is we're going to Mexico. We're going to the superstructure. We've reproduced that in the Bahamas, in Colombia, and Honduras, etc. It's a deck-on pile, so it's on the east coast of the country. Deck-on pile, also designed by Carlos and his team from SGH in Houston. It's a marginal wharf, and it's all these areas are very seismic areas. The structure is the use of precast, as you know, and I want to stress out again. It accelerates the rate of construction, so we are focused on that. And the solution is a precast elements So yeah, thank you. Superstructure made of precast elements on the steel piles. So I'm not going to focus on the steel piles and more on the superstructure. There are high loads. There are ship-to-shore cranes, mobile cranes. The uniform load is 1,000 PSF, around 45 kPa. And the piles, the most loaded piles are in service load 355 tons capacity. About the seismic, we developed there, the code is too conservative, so we did a site-specific seismic survey, and this is something that we do everywhere to have more precise information. The zooming in the type of superstructure, so we drive the pile, and after we have the superstructure, the deck is composed of precast beams and planks, precast planks, and a topping. And to connect the pile to the beams, we have developed in the past years a precast pile plug, including the subcap, that is grouted inside the top part of the steel pile. Carlos, I've used some of your information. This pile plug is acting, is transmitting all the horizontal loads, the compression on top of the bottom, thanks to his contact from the precast through the grout to the steel of the pile, the pipe outside. But the vertical load, it's important to mention that it is resting on the top here, on the top of the steel pile. So all the vertical loads are going through there. So it's actually transferring the moment from the pile towards the superstructure without any interference of the friction of the grout with the precast and the grout with the steel. The seismic capacity protection has been checked, of course, for this wharf. So we have the solicitation coming from the ground and transmitted to the top of the pile. The top of the pile it's creating a moment, and the reaction to the moment is coming from the superstructure. It's not all uniform because the beams are not all the same size, so some attract more than others, and all this is defined. These sections are defined by the designer. Also compared to the repairability of the damage. Here we can accept some damage. There are operation levels, earthquakes, contingency level earthquakes, depending on how quick we want the wharf to be operable again. You have to adjust the size of these concrete elements consequently. As I mentioned, this is not all the steel that we have, but the beam and the 3D modeling is a must here, because we have optimized all the dimensions and we are using a lot of precast, but it gives a very small area and volume at the closure pores, so it's necessary to have it all planned in 3D and with also some tolerances. Some pictures here. So the pile plug installation on the left, which is grouted. This is me. So you see these are the smallest ones. On top of them, we installed the precast, so full section, plain section precast beams with the appropriate walkways for the safety and the access of the workers to the closure pores. This is the closure pore. This one is easy, it's monodirectional, but these one are two directions. So it's quite dense in steel. After the pouring the closure pours, we installed the precast prestressed deck planks that we can see here on the left. We add the topping reinforcement, and this is the first pour of this wharf on top of it. And here we can see all the three. We can see the piling that is almost done on the north part of on the right, and you can see also that we have implemented some top-down solution. So we are working on the driven piles with the temporary steel deck. So these takeaways from these three topics. As I mentioned, the massive use of precast concrete is for the deck, and seismic and hurricane activity region has been implemented, and there and in a lot of projects it gives a lot of reduction in total concrete volume, especially if you don't use tub type precast. These are plain sections participating fully in the resistance of the structure. High performance concrete mix designs, and overall this gives a reduction in the carbon footprint. It's quick to install the piles, concrete or steel, but also the deck and these elements are of course easy to install. Beam is required, as I mentioned. Work is ongoing. The ACI, work ongoing or has been done related to these topics. Precast applied to port and or seismic environments. So ACI 318, the ASC 61, and the PIANC also is preparing its new report, with including this precast plug and seismic design of piers. And lastly, I want to highlight that you guys have a lot of influence in the whole region and continent. Many countries are taking your regulation and your recommendations for application locally. So okay, so keep up. So acknowledgements. So I thank the PROCEMCO, the Colombian Chamber of Cement and Concrete, that invited me to present this in the name of my colleagues in the whole region, my co-authors from Colombia and the whole region. These are the logos of our company, and present here also you may know Nicholson, and Carlos and his team here, SGH. Thank you very much.